Please take your seats. Be careful with the coffee. Okay, and I'm passing the floor over to Michael Bright, who will be talking about serverless.
Thank you. Good morning. So I'm Michael Bright. Actually, this is a lie. Until Wednesday, I'm working at Hewlett Packard, where I've been for the last 32 years. But Thursday, I will start working for Containers. Container are the guys who create traffic, the reverse proxy load balancer. Some of you might know. Okay, anyway, I'm not here to talk about that. I'm here to talk about serverless or functions as a service. Okay, so what I want to do is talk about serverless, what it is. I guess most of you have an idea if you've come here. It'd be interesting just to get an idea of your experience with it. I want to look at the different cloud provider offerings. I'll be looking fairly wide. Okay. Then the fact that Cloud Native Computing Foundation has a serverless working group now, because serverless is becoming a very, very popular subject, so you know. I'll look very briefly at the serverless tools, actually just one or two. There must be 20, 100 different open source projects around serverless. And then serverless platforms. What I mean is some of the open source serverless frameworks which you can use to do serverless on your machines. So I'm thinking OpenWhisk, OpenFaaS, so on. And then serverless in action. Okay, so I need to breathe deeply. I woke up this morning and I had a host of serverless demos on in VMs in a machine in Geneva, and my jump host was down. I actually tried 5 minutes ago and it was back up, but now I'm not quite sure what I'm going to demo. So we'll see how it goes. Okay, so what is serverless? No more servers? No, of course. Serverless, some people don't like the name. I personally do, but serverless is all about meaning that developers no longer have to worry about servers. They don't have to worry about installing physical or virtual machines. They don't have to worry about updating those, patching the operating system, this sort of thing. So that's what we mean by serverless. So if you look at how we got here, really I see it as a continuum as we've gone from sort of monolithic applications running on bare metal through to virtual machines, cloud, and function as a service or serverless is really the last sort of instantiation of that, sort of the lightest weight, most sort of cloud native implementation. So if we look at those, obviously bare metal servers, if you deploy something on a bare metal server, you really had to take care of the servers. I mean, we don't even think about that, but the first thing you have to think about if you're in a data center, well, where I'm going to put my server. I need cooling, I need power, there's all sorts of very physical implications there. And of course, well, for 15, 20 years, I mean, most of us have been using virtual machines now, so we don't have that consideration, but we still have to manage our virtual machines, install an OS, patch the OS maybe, and this sort of thing. And then cloud, well, if you're talking about IaaS, it's the same thing as the VMs in terms of management. And then we have higher level of service, like platform as a service, things like OpenShift, or software as a service, so actual end user applications, like Google Mail or whatever. So we're sort of raising abstraction so the user has to worry less about physical machines and gradually less about virtual machines. Then we have containers, of course, which simplify things again, but still require some management. And now we have serverless. So serverless, it's actually been around for, I don't know, 15, 20 years. I think maybe Iron.O was one of the initial people working that domain. But it's been largely popularized since Amazon launched their Lambda service. So they announced this as a beta in November 2014, and it was 2015 that it really started being something usable. And now all the other major cloud providers are also providing serverless platforms. And we'll see there are several on-premise solutions as well. Okay. So I see serverless as really this continuum, getting something to the what I would call the ultimate in cloud native. Okay. So I've said, what is it? Well, it's really about not caring about servers. I won't repeat myself more there. It's also about so both backend as a service and functions as a service. If you wonder, so why did Amazon get interested in serverless? They had a quite good business running around YAS, running VMs in the cloud. But they found that more and more that what people were implementing was applications that would essentially be glue code accessing their backend servers, DynamoDB or the SNS notification service or whatever. So all of a sudden for them, function as a service means that they're actually going to sell on a lot of these back-end services, which are the ones that will bring in revenue for them. Okay, what's interesting about serverless is it's really pay-as-you-go, nearly. So, in theory, you develop a function or a set of functions, you deploy those to your service provider, and then you will actually start paying once those functions are called. And typically, the different service providers allow you something like, I think, 1 million requests a month before you pay anything. So that's really pretty interesting. And in particular, if you're a startup or you just want to innovate and to try out something new, it means you've got quite a lot of flexibility without actually paying anything. That's the theory. There was an interesting article just last week. Actually, last Friday, I was presenting, and about an hour before I got this in my mailbox. Some guy had done an analysis of a particular deployment. It turned out that analyzing this particular deployment, I think 1 or 2% of the costs were the actual function requests. 70% came down to the actual Amazon API gateway. Okay, so in general, yeah, you've got to be careful. It's snake oil. If we just look, in that article, there was just a comparison of the different service providers, and in particular, this last line, the API gateway. We see that IBM and Azure, the use of the API gateway is free, but with Google and Amazon, they both pay quite a hefty price. Okay, so I just wanted to come back here. So it's just say this, pay for what you use, yes, but be careful, there are gotchas. There's no initial investment, okay, so you don't have to buy a machine, you don't have to even pay for a VM, you just upload your functions. So it's going to be pretty good for startups in particular, any agility, because you can have very short time to market, test things out. Also, another theoretical one is massive scale. So it's now the responsibility of the service provider to actually scale up. Basically, if you're making 10 requests a second, fine. If you're making 10,000 requests a second, it's the responsibility of the service provider to launch sufficient containers or VMs or whatever implementation they have behind that to satisfy that demand. There again, on theory, I've seen some reports that the scalability isn't always quite what you expect. As I say, some people don't like the term serverless. Maybe just the name they don't like, but also personally what I don't like is also the name of a company, and it's also the name of the tool of that company. We'll come back to that. So either serverless or function as a service, whatever you prefer. Okay, that was great. Okay, so if you look at the architecture, there's actually a missing block in the middle. That's the API gateway. I guess it's the elephant in the room we don't want to pay for. That wasn't intentional, but okay. So the basic idea is, you have your code, your function as a service that you're going to load up into the cloud. That could be self-sufficient, but typically you're going to use some functionalities on the right-hand side, the back end of the service of your cloud provider, or maybe from a completely other provider. That concerns people saying, well, okay, but then you're going to have a lock-in. Okay, yes, but that's a choice. No one will force you to use those services. It's because you want that functionality. So those backends of service typically will be something like a notification service, storage like S3 for Amazon, or database, DynamoDB. So a very typical use case might be, for example, uploading a file into S3. That will create an event which will trigger your function, and then you might process that file, let's say an image, create a thumbnail, whatever. And then there's a whole set of other events which actually could come from one of your own functions or be coming from the outside, so they'll be coming through the API gateway. So an obvious example is, obviously, a request coming from a web browser. It could be some time signaled event, or it could be webhooks from like GitHub or Docker Hub. You're checking an image, you do a commit of a repo, triggers an event so that you do some processing behind that. Okay, and so as I say, at the middle there, the events part, there's this API gateway, which you don't actually see there, but this is essentially your front end allowing or not requests to come in and get to your function. Obviously, you don't want just anyone to be able to call your functions, or it will cost you a lot. Okay, if we look at use cases for serverless, so basically, anything that's periodic or maybe unpredictable with high peaks in traffic. So I mean, an obvious question already, if you look what I presented, well, how does FaaS compare with platform as a service like OpenShift? Where would you want to use serverless rather than PaaS? And the thing is, it all comes down to utilization. If your function is something that will get invoked like once a month to do the payroll and then not used the rest of the time, then that might be expensive on a PaaS if you're not sort of mutualizing it with other functionalities. So it's really either very short, very peaky functions, or they're either regular or unpredictable. Those are the ideal use cases, but there is another point, the characteristics here. You don't necessarily have good latency on the serverless, okay, so you want to be aware of that. I think we're typically looking at 100 milliseconds or so. That said, these are still early days for serverless, and it depends obviously on the implementation, the language implementation. I forget the figures now, but there's some public blog posts on comparisons of Node.js or Python or whatever on AWS Lambda, and Java, of course. Obviously, Java has a warm-up time, which is quite heavy. Python, I think, is one of the better languages in time. But that's all stuff that could evolve anyway as platforms get optimized. The thing is that your application should be latency tolerant, or at least should be able to handle at least tens, maybe hundreds of milliseconds response time for it to be suitable for serverless. As I say, it should be short-lived as well. If it's something that's just going to, let's say, be running at even 10% utilization throughout the whole month, then, well, you might as well just implement it in a more standard way on a PaaS, for example. So look at domains. Well, banking is one particular example. So things like processing checks. There are banks that have done this with serverless. It's quite an ideal application. This is something that is done, again, periodically with a high peak in charge and using something relatively heavily in processing, image processing behind the scenes. IoT, we see that AWS with Greengrass are looking at use of serverless. And generally, where you have a lot of sort of back-end services and you just want the glue logic to be able to process. So if you look at the different cloud provider offerings, so obviously Lambda is the real thought leader in that today. So as I said, they announced Lambda November 2014 at reInvent, but it was end of 2015. It was really functional. But that nevertheless gave them a head start on Azure and Google. So Azure, they seem to be going full steam ahead with functions. Obviously, Microsoft have an advantage. Maybe here won't be appreciated so much, but clearly Microsoft do have a lot of development tools. Personally, I'm not used to them, but a lot of people are really used to Microsoft development tools, and having good integration with serverless on Azure could be a real advantage for them. Actually, on that subject, Amazon, they bought Cloud9, of an online IDE, a year ago, and we're starting to see that being integrated into the Amazon, the AWS website, so you can modify code and deploy that directly. Google, okay, I have some slides which look a little more detail at the different providers, so I won't go into them all, but you can see there are quite a few. I see these top four as the main players, though Oracle and Pivotal seem to be quite active. Spotist is a smaller one, but seem to be quite active as well. So Lambda, I mean, probably the most interesting thing is language choices. So these serverless platforms generally use containers, so we might not know what's behind the scenes, so we're not too sure of the detail with Lambda, but it seems they do use some container technology, and they actually, rather than spinning up a container for each request that comes in, which they could do, they do seem to reuse containers, but only during a certain time. There's an idle period, I think, after about 5 minutes, containers are cold, okay, which means that if they go unused for 5 minutes, especially if it's something like a Java, a JVM, if you get a request that comes in after 20 minutes, if you don't do something to keep it alive, then you're going to pay a pretty hefty startup time on that. So they support Node.js, Python, Java 8, C#, and there also is a project, an open source project, I can't remember what it stands for, CSER. It's something, containers something as a runtime, or no, I probably got that wrong. Basically, it's an external project allowing you to invoke containers, which essentially is opening up the possibilities beyond just the languages that Amazon provide. The advantage of the languages that Amazon provide is that they will be well integrated with their backends, if you want to use those, well integrated with their SDK and CLI. And then very recently, they've added, I say recently, it was announced at reInvent in November. They will support Go and also .NET with C#. So Go now is available, last week or so. There's been a few blog posts on using Go with Lambda. The only gotcha it's there's a plus and a minus. It's actually, unlike the other languages, you actually deploy a Go binary. So you compile a Go binary and you upload that. So on the plus side, that means that it should be fairly easy for them to extend that to other languages with static binaries. On the downside, it means that it won't be well integrated, at least first of all, with the Cloud9 IDE. I mentioned cost, so yeah, typically you've got 1 million free requests a month with these platforms, which is pretty good, and then there's very small cost for once you've reached that limit. They're fairly similar, but I guess you really have to calculate once you're up into the millions and millions of requests a month, and the differences start to be felt. Sometimes felt it's a little slow. There are relatively few languages available, and people are afraid of lock-in. But again, I say that the lock-in is a choice. In fact, there's some real lock-in with these platforms in the sense that they don't have a common definition of events and things. But in terms of use of back-end services, then that's clearly a choice. Okay, Azure Functions, quite a few languages available. Obviously, Java, JavaScript, C#, F#, languages that they have as pretty well first-class citizens. Pretty good developer tools available for that. Still fairly young. Again, the lock-in, same as for Amazon, that the events are quite proprietary today, and use of back-end services, again, it's a choice. Google Cloud Functions, I don't know too much what to say about this. It's very young. The last time I looked, and I didn't recheck this today, they supported only JavaScript, but I'm pretty sure I've seen Go coming on. I mean, Go seems a no-brainer for Google Cloud Functions. But I'm not really sure where Google are going with that. Well, I guess Google's a big company, and I mean, I've asked people, and they don't seem to know, but I guess it depends who you ask. IBM Cloud Functions. So they developed a project called OpenWhisk, which probably some of you have heard of. They actually donated it to the Apache Software Foundation, so it's now Apache OpenWhisk. So that's something that you can use as one of the on-premise platforms I'll talk about. And they deploy that on their own IBM Cloud. So the two languages they support directly are Node.js and Swift, curiously. Apparently they had a pretty good deal with a customer around doing iOS mobile applications. That's why Swift is in there. And then the BYOC is bring your own containers. So natively, Lambda and Azure don't allow you to just load up your own like Docker image or whatever, but IBM Cloud Functions do. So it's quite a good open source community about that, and in particular, there has been work on integrating OpenWhisk with OpenShift. Okay, so all of those have some degree of lock-in, but we really need something more open for serverless. And so the CNCF created a serverless working group with representatives from pretty well all the major platforms. Actually, I don't think AWS is in there. Yes, they are. Yes, they are. Sure, indeed. And their goal basically is to provide clarity on the topic, make sure that at least the terminology is the same across the different platforms, define the scope of serverless, what does it mean, and also to define things like I mentioned events, how the definition of events will be different for the different platforms. So CNCF wants to not just define terminology, but really the semantics of some elements. they've created, so I mean there are many things they're doing. In particular, they've written a white paper, which is pretty interesting. Recommend you read that. There's a CNCF Slack channel specifically to serverless, and their regular meetings are available on YouTube. Okay, so if we want to look at serverless tools, actually, as I mentioned, I mean, there are maybe 100 different open source tools. There's really just the first one I wanted to mention. I mentioned that the only thing I don't like about the serverless name is that there's a company called Serverless, the first one here. Serverless, okay, this is their website. So they provide a framework which will allow you to do the same operations, whether you're addressing AWS Lambda, Google Cloud Functions, Azure Functions, or IBM Cloud. Okay, so that's quite interesting. It's trying to prevent lock-in and allowing you to just use those same steps to deploy to each of the cloud providers. And they also provide an event gateway as well to facilitate passing of events between the platforms. So there's the cloud providers they support. I thought there was a list of, okay, there are also platforms like Kubeless we'll look at that they support. Okay, so that's an open source project, but they also have a sort of premium service behind that. Apex, I'm not going to talk much about, but it seems to be a similar approach of just providing an abstraction above the particular serverless platform that you're using. I've not used Apex, but it's a similar approach. And Chalice, I picked out this one. I mean, it's an open source project on GitHub, just facilitating deployment of Python serverless functions to Lambda, okay, and it is an AWS project. So I mentioned that one, but you should know there are at least 5, maybe 10 different Python-specific serverless interfaces to Lambda. But that's the sort of official one from AWS. Okay, I'll skip these. Okay, what's more interesting to me is the actual open source frameworks that are available. Let me see. I think most of them, no, they're not true. The first two anyway really target Kubernetes. So Kubeless, I'm not sure, I think it came from Bitnami. Fission from Platform 9. Apache OpenWhisk, as I mentioned, came from IBM. OpenFaaS basically comes from the Docker captain Alex Ellis and is largely supported by the Docker community. The FN project, I believe, is a fork of what Iron.O did initially and is now an Oracle project. So I think they deploy that on Oracle Cloud, but it is nevertheless an open source project. Nucleo is a small Israeli company, again an open source project that they all are. And what they're doing is they're really targeting big data applications, and they're putting a focus on response times. Okay, and they're fairly young. I don't have experience using them. And then Pivotal have Spring Cloud functions. So what I wanted to do was to look at OpenFaaS. In fact, in a data center in Geneva, I have about 4 or 5 of those deployed. And as I say, that I didn't have access to those today. My jump post went away. That was a nice surprise this morning. So in the end, I have bits of demo of OpenFaaS and not the other platforms. It's just that I haven't had time to check out the demos. So I'll show a bit OpenFaaS. So basically OpenFaaS, as I say, comes from Docker captain Alex Ellis. He's done a brilliant job of not just developing OpenFaaS, but building a community around it. It's probably one of the few, if not the only platform that doesn't have a major vendor behind it. All the ones I just showed you, Kubeless, Fission, OpenWhisk, and so on. They all have a vendor, if not a major vendor, behind them. It's strictly bring your own container, okay? So you build a Docker image using some templates, you upload that into your platform, and from then on it's functions as a service. Okay, there's a version fastnetis that runs on Kubernetes. There's a command line tool. Actually, probably all of them have also a command line tool and API for dealing with them. It's fairly young. This existed for about a year. I think he demonstrated it first at DockerCon in Austin in April. For me, the real differentiator, in fact, why did I decide to demo OpenFaaS today? Well, I was going to, but I wasn't quite sure if I would demonstrate OpenFaaS, OpenWhisk, etc. Is when I didn't have my jump host available and I had to do something locally. OpenFaaS is probably the easiest one to get started with, and there are a lot of good examples. There's a really very vibrant community and a lot of blog posts about interesting projects. So, I forgot I added these slides. Okay, just one example. Johnny Michael, who he basically used OpenFaaS with TensorFlow to do some image processing. Okay. So this is just a blog post that he did where he took a series of images and he was applying some styling using TensorFlow to manage that. Okay. And so, okay, that was fun, but it's one of the interesting applications, very easy to do with OpenFaaS. Another one is Finian Anderson. This is around about DockerCon. He was demonstrating this. I mean, I think Finian is like 19 years old or something. And so he basically went from examples of colorizing black and white images. I think it's using TensorFlow to actually colorizing video, which is just the same process, of course. I mean, it's breaking down a video into a set of sequence of images and then individually processing each image and then reconstructing the video. So this is a blog post that he did about that. And there's a link to, there it is. Okay. There's a link to an actual video that he'd processed. So you see the black and white original and the colorized version. Obviously this isn't, well, this is YouTube, but creation of that image isn't real time, okay? It's something that's done offline. But it still functions as a service. Okay. Okay, so OpenFaaS. I want to do a demo of OpenFaaS. So I'm a bit limited. So I've got OpenFaaS running on my own machine. I'm actually running it within Docker machine because generally you take the last OpenFaaS. It tends to depend on the latest Docker Compose, the latest Docker engine. So it's just easier to create an environment in Docker machine. When you just start it, you've got a set of base functions already there, which you know go from the most basic hello world. Basically, we just enter request body, we invoke the function, and we get the result. Nothing amazing. I could do that same function from the command line. I'm not going to try because I don't remember how to form the URL. If I'd had my original platform, I had it all scripted and ready to go. But okay. Obviously, these are very simple functions. This one just creates some HTML from from some markdown. I do an invoke, and my markdown has been converted into HTML. What else? Node info just tells you information about the host on which we're running. What else? Okay, base64 conversion, a webhook stash I've not used, but I guess you can basically hook into some GitHub webhooks or Docker Hub. Okay. What I wanted to do, okay, so I just sat in this room, I scripted up a quick demo. Basically, I didn't have access to the one that I'd already prepared, so I quickly did this. So it's a bit basic, but it's just to give you an idea of how quickly you can deploy a serverless function. Okay, so this command line tool, FaaS CLI. So you can see the set of commands you have available. As is often the case today, they're a bit sort of a Docker-like commands, sort of a build and push and this sort of thing. If I list the services that are available to me, so I've actually port forward into my Docker machine, and we'll see the functions available. So this is the same list you recognize from the browser a moment ago. I'm going to create a new function. Okay, don't expect anything amazing here. This isn't going to be image processing. This is going to be hello world, folks. Could have been better, but anyway. So basically, FaaS CLI, new. I give the name of my function testpy, and I specify that I'm going to be using Python. What does that mean? It means that it's going to build a new image, but it's starting from a Python base image. Okay, so that will have created a set of templates for a generic Python application. This testpy.yaml gives a description of the function we're trying to build. So the provider, so it's just a pointer to our default OpenFaaS server. Lang, again, it's telling us about the base image and the image we're going to create. And it's created a testpy folder in which it's created a basic handler in Python and a requirements file. Because it's Python, then you can specify a set of requirements to install by pip. Okay, if we look at the handler, okay, it's really just taking an input, taking a body and printing it out. Just show it's not completely canned. I'm going to modify that to welcome to OpenFaaS. Amazing. Except this is DevCon. I must learn to type someday. Okay. I forgot I had that. Okay, I'm going to overwrite it. Never mind. That's the problem with scripting demos. Never mind. I will cheat. Okay, we'll really have that updated version. Okay, and I'm now doing a build of that. Most of that was cached because I did it just before. Actually, it was failing earlier, so I couldn't access the Docker Hub for the Python-based image. Okay, I'm going to deploy that. Okay, and so we see that, okay, I've deployed and it's deployed it through to this URL. So I could have used that actually, right? I'm going to just copy that, do it from the command line later. Okay, if I do a list now, we have the test py in there. It's curious, it's saying 15 invocations. Okay, clearly clean up from my test run, hasn't completely been cleaned. Okay, and now we see it in this list, it wasn't there before. I don't know, okay. Anything? Yes. Well, actually, I must admit it wasn't working earlier. This is a demo that I just quickly put together. I had, as I say, I had a working one in my Geneva system.
I think it's because it's doing a Docker pull of the image from Docker hero, whereas if you had deleted the YAML file, you could have specified to use a local register.
Okay, yeah. Yeah, right, yeah.
I believe.
Okay, never mind. You see the principle. Okay, I like that. Okay, so, and if I, okay, so this won't work either, but if I'd wanted to do the same thing, I think I just use that URL like that, but okay, it's going to be doing the same thing as doing an image pull. Okay. So, pretty poor demo, sorry about that. I would have much preferred to have been preparing my Kubernetes tutorial. Starts in half an hour. So, I mean, serverless is still a relatively new technology. It's becoming very popular. I think it really will gain a lot of traction over the next few years. But these platforms are still fairly young, and people still need to understand the use cases where it will work well, where it will really save money. There's some risks there. It seems like all the major cloud providers are investing in that. But today it's, you make a choice, and it's still fairly proprietary. So it's good to see the CNCF involved trying to standardize some of that. I consider it's the ultimate cloud native because we're really abstracting away from the hardware and the operating system. There are many choices today, not just of the service providers, but also these serverless frameworks like OpenWhisk and so on to choose from. Yeah, still early days to really be sure of the performance and so on. So that's something to be watched. And there will be many, many blog posts, I think, in 2018, comparing platforms, comparing languages on the different platforms. But it's really a domain it's worth investing in. Okay, I'll stop there. I've also got a list of just some resources in my slides. Any questions? Yeah.
So as far as I understand, the serverless framework sort of sits between the traditional services and servers in the back and the application development. So it's another abstraction which sort of mixes workflow related and function related. So the question is, what will be your recommendation to the projects and products that implement the backend servers, traditional ones, to become serverless ready?
Serverless ready. I mean, you basically need to be able to, I'd say, instantiate containers typically, and to keep them warm. That would be a matter of using one of these serverless frameworks that we've mentioned. I wouldn't recommend reinventing the wheel there. There's plenty of open source choice there. Bear in mind, containers might not be the only solution. Maybe unikernels at some point. Unikernels are something that may not be of such general usage, but specific use cases. And in particular, imagine that you can, if you compile a function directly to a machine image, which can be fired up very quickly, then Unicorn suddenly becomes a very interesting use case for serverless. But that's future. Okay. So today, I would say, go with one of the open source serverless frameworks.
Well, it's more about, okay, I have a database. Let's say I'm Postgres, so I'm MariaDB, whatever, right? So what does that mean? Do I need to have an API to be deployed, managed, REST API to do operations so that it can be plugged in easily into all these languages that are running inside the serverless functions? Or is there anything else specific that drives?
Sure. Use the example of PostgreSQL. All of this depends on the APIs that are available. So I guess if you are wondering about a particular backend service, I guess to facilitate language bindings. And otherwise, then the different serverless frameworks come with their own deployment tools. Yeah. Okay. Yeah.
So, have you evaluated all those the open source offerings on Kubernetes or OpenShift? And if you did, can you provide feedback on the different patterns that they use to actually implement serverless functionality, let's say?
Yeah. To be honest, I haven't used them enough to really compare. I think they have fairly similar models. More and more we're seeing a lot of sort of the same sort of command sets. You have different experience?
Yes, I have a different experience that I tried the Fission and OpenFaaS on top of Kubernetes or OpenShift.
Yeah.
In the case of OpenFaaS, it's interesting to see that they leverage a lot of the Kubernetes project.
Okay.
So they create deployment for every serverless function, for instance.
Oh, okay.
It's a nice pattern, deployment pattern.
Okay. Yeah, I actually tried to install OpenFaaS and OpenShift this morning.
We have questions on the website, sorry.
I already wrote a few serverless functions, and but as you can see here on your demo, even the very basic functions usually are failing at the first deployment. Do you? I think it's general thing. Do you have any recommendations for the testing frameworks? How to make them
Okay.
to run and deploy?
Okay. So just to make one thing clear, I just made the worst OpenFaaS demo ever, but it really was because anyway. Yeah, I think testing is another area where we'll really need common tools and approaches. And even just having played a little with Lambda and via the GUI, they provide a basic way of just like one test event for one function, this sort of thing. But you need something that's even just a suite, and even that isn't there yet.
Functions are different based, so you need to somehow generate these events for testing.
There's a big risk. We like microservices, but you can see there's a risk of like microservice sprawl, and functional service is like the next level nano services, and things could be a real mess if we don't manage them well and if we're not able to test in the right way. So yeah, I don't have the answer, but that's definitely needed.
So, is there any real-world application that you can tell us about?
Okay.
That is,
Okay. So sorry, I haven't been repeating the questions. I just realized I should do. So are there any real-world examples to demonstrate serverless? So the publicly accessible ones, I can't think of one, although I've shown blog posts of things, then they're not actually online that you can use them. The colorized one for images actually was online. There was a demo where you could tweet a black and white image, and you would get back a color image. But that was something that was like temporarily online. Otherwise, there are examples of them really being used in production, but they're not something that are available there, you can just access. I'm thinking of examples. There was an Australian survey where apparently it cost millions of dollars to develop this survey, and some guy had come along and just re-implemented it in serverless, and it was just a fraction of the cost. Banks are using this to process checks, as I mentioned. I wouldn't like to name a bank. I think Capital One. I'm worried of saying the wrong name. But there are real use cases. And in fact, even the case, I don't know what it was. I mentioned the article from a week ago. So this is a real use case, but I don't remember what maybe this Campus Explorer. I must admit I didn't delve into what was the actual use case. But that's an interesting blog article to look at for a real example. Okay, it's being negative on lambda, but still, I mean, it's just saying there are hidden costs. Yes. So yeah, it's pretty similar to the testing thing. That's something where there will be need for tools. Very early days, and that will be a problem.
I can answer to you. AWS provides X-Ray as a debugging framework for AWS Lambdas, and it's working pretty well. Not for the beginners, but then if you use all the concept of looking into the Lambda functions, you can really find some constraints of performance of your functions. So if you are in the AWS world, just recommend to X-Ray.
So we have